Okay, welcome back. And today what we're looking at is the idea of the law of diminishing returns. Now, remember yesterday we looked at production possibility frontiers and just we drew a very basic production possibility frontier which had corn on one axis and wheat on the other. And it drew a very simple and straight line showing that as we transfer our resources from production of corn, what we give up in corn, we get in wheat. So remember we had a very limited resource on we talked about Farmer Joe. And if you remember, Farmer Joe had 4 fields which he could use for either corn or wheat. And so the limited resource that we had available was land. Now, that was a really good example to illustrate the idea that a PPF shows all the different possible output combinations using whatever limited resources we've got, in this case land. But the trouble with this graph was that it's not actually that accurate because most resources aren't the same, and this tends to assume that all those resources, those 4 fields, could equally produce corn or wheat. But if you think about it, if you think about a normal farm, it's got some very flat land like this, and then it's got some hilly land. And generally what farmers will do is they'll use that hilly land to grow the likes of trees, and they'll put the cows and the sheep on the fields here down in the down below on the flat land. So some land's suited for one thing, some land is better used for other output. So really we've got to make our analysis a little bit more sophisticated to actually get a proper PPF. So again, let's take that example of timber and wood, and we're going to take a basic farm again, and we're going to say, okay, it's got this time rather than 4, it's actually got 9 fields. And we're going to break that up into 9 fields. Now some of these, and I'll just use a letter to initiate, are more hilly and they're much better suited to timber, whereas some of them are going to be used to produce wool because they're flat and they're really well they're drained so that we get really good grass growth. So these here, they can make 2 lots of timber, or they can be used for 1 lot of wool. Now these ones are just all the same. Okay, they're equally productive. They can grow 1 timber or 1 wool. Now these ones here, these are really good for wool, and so they can be used for either 1 timber or 2 lots of wool. Okay, so the one on the left is timber or wool, timber or wool, timber, timber or wool. Now that's actually a much more realistic scenario. Now if we try and draw this, I'll just start with the vertical axis, which isn't terribly well done, but we start with, again, we've got 9 fields, so let's say we can use that to produce, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lots of timber, if we put it all into timber. Now, if we took one of these and said, let's shift this from timber and put it into wool. Logically, you wouldn't use this land over here because that's best for timber. You'd use the stuff which is best for wool. So we're going to take one of these ones, and we'll just scratch that out as we go, and we're going to shift it. So we get not just 1, but 2 extra lots of wool, and we give up 1 lot of timber. So we've gone down to 10 outputs of timber, but we've picked up 2 lots of wool. So again, let's take the second one here, and we take that out, turn it from timber into wool. Turn that off. So we go 1, 2, and down 1. So now we've got 9 lots of timber, but we've got 4 lots of wool. Now if we keep going, we'll do one more before I get going. This one here can be used for either timber or wool. So this time we would get increase in 1 lot of timber, and 1 lot of wool, but we only lose 1 lot of timber. So we end up with down to 8 and only up to 5. And again, we can do it 4 more times. 1, 2, 3, 4. So let's do that. So 1 more, 2 more, 3 more, 4 more. So we've got 7 and 5, 7 and 6, 6 and 7, 5 and 8, or we can go 4 and 9. Now, What about these last ones here? So we've used up all these ones over here. What about these last ones here? And this one, to get one extra output of wool, we've got to give up 2 lots of timber. So we would go, yes, we grow by 1, but we go down by 2. So that's not such a good one for us. So we get down to 2, and we go up to 10. And the last one, same thing. We go increase by 1, but we lose it by 2. So we get 0 and 11. So we'll just finish off that graph. Now my graphing skills, there we go. Okay, and we'll just finish this off. So there we go. Now if you actually drew that, if you draw those dots up, I won't try and do it here, but if we did it properly, you'd get a graph that looks something like this. And that's what a PPF normally looks like. And we describe that as being concave to the origin. So we'd put timber over here and wool over here. And remember, the reason for that is because not all resources are the same, and as we transfer them, initially we get huge gains in output of wool in this case, but initially, and then we get sort of moderate gains, and then we're going to get very slight gains. And that's the whole idea of diminishing returns, that as we transfer resources from production of one good to the other good, initially the output is great, the increase in return is great, but the increase in return gets smaller and smaller. Hence the idea of diminishing returns. Our extra return and output gets smaller and smaller. Okay, and that's the idea of the law of diminishing returns. And it's why the production possibility frontier, or curve, is concave. So the cave is concave to the origin. And you can see here, here's the cave, and it faces the origin. Okay, so that's the law of diminishing returns.